To begin, please sit in the book and students in the book. We have a few housekeeping notes to make for reviewing today's program. We would like to seek your cooperation and kindly switch your mobile phones to silent mode to avoid interruptions. Thank you for your kind consideration and attention. So now, to formally start our program for this afternoon, may I request everyone to please rise for the invocation to be followed by the singing of the Philippine national anthem.
Ng ating lahi, kabilang sila sa paglinang ng ating makulay na sining at mayamang kultura. Kasapi sila sa pagtataguyod ng mga adhikain ng kapwa mamamayan at sa pagtugon sa mga pangangailangan ng lipunan. Katuwang sila sa pagtuklas sa mga larangan ng agham at medisina. Kapanalig sila sa pagpapairal ng batas, karapatan at katarungan para sa lahat. Kabahagi sila sa paglilingkod sa bayan at sa pagpapanatili ng demokrasyang Pilipino. Sa paglipas ng panahon, hindi nagmaliw ang kanilang pag-ibig sa ating inang bayan. Mga kababayan, ito ang alay ng mga kababaihang Pilipino para sa bayan. Tumayo po tayo lahat at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Puedes decir nada, anak berpuso, sering buhay, rumah pilihan, berkadang memiliki, saat dulu, itu kasih sini, saya datang dulu, sisi rasa dari orang, bagi datang dulu, tahu bisa, dan diaman, yang mau berikan kepada diri,
So you may have your spot. Thank you. Our university officials, Dr. Vladimir Ronda, Director of the Extension Division, our Vice President for Research Innovation, Dr. Ramona Isabel Ramirez, our Vice President for Academic Affairs, Dr. Ana Miranya, and to our SUC4 President, Dr. Alberto Peña Perry, magandang hapon po. And of course, to our Deans, Dr. Yamari Martiras of PNR, and Dr. Jennifer Ibonia of SEX, and to our chairpersons of different departments and programs of the sub-colleges, co-faculty members, and to our dear students present this afternoon's event. So from Bachelor of Agricultural Technology, we have 25. You may stand up for you to recognize. For the BS Agroforestry, we have again 25 students. For the BSA Agriculture, we have 60. So 14 from the major of agronomy. We have 13 from the farming system. Thank you. 13 for horticulture. 5, we have 5 for soil mixture. We have 5 for plant ecology major. Then we have 10 for entomology major. And we have from SEP, Biosystems program, we have 5 students. Once again, a pleasant afternoon. So this is an event organized by the Agriculture and Innovation Center, College of Agriculture and Natural Resources, College of Information Technology of Secaucus, and CBSUA Extension Services. For the information of everyone, last December 5, 2020, the CBSUA Agriculture Research Initiatives was conducted in partnership with LDLE Smart Hub AI, and it was held at the CNE Hall of the CBSUA of this university. And now we are here in this seminar entitled Soil Plant. Based on research, it is said that artificial intelligence is a new tool for agriculture, where recent scientific advancements, breakthrough results, and the success of particular applications have brought artificial intelligence into the spotlight. AI systems are already being deployed or piloted in many sectors, including automated financial, manufacturing, health, security, and government, and now in agriculture. So without further ado, to begin with the program, we are pleased to have our VP for Research and Innovation, Dr. Ramona Isabel S. Ramirez, to be with us.
Sabi ko, baka hindi ako makita doon. So I let them stay here so that everybody will see me. To our dear resource person, Dr. BENG UMALI, to Dr. Vladimir Coronda and his team, to the rest of the uh, members of the academic community of CBSUA, the deans, also our, if the campus administrator is here, um, our dear students, and everybody, good afternoon. Internet of Things and artificial intelligence, digitization of agriculture is one important factor to development. And so because Central Bicol State University of Agriculture, being an agricultural research university, makes it a point to really disseminate information and awareness among faculty and students, something about digitization of agriculture, primarily because we would like all of us to be able to respond effectively, efficiently to things that are relevant on ICT development as well as agricultural development. So that for today, we are so happy that the Digital Agriculture and Innovation Center headed by Dr. Vladimir Coronda in cooperation with all the other units and colleges in the university spearheaded this very relevant initiative so that we can disseminate knowledge and information on digitization of agriculture. As such, allow me to welcome you all in this very relevant activity and may you all enjoy the lecture and benefit from the knowledge that you will gain from today's activity. Good afternoon again, and God bless us all.
Thank you very much, Ma'am Ramirez, for that warm welcome. And to proceed, to give us the background information about the CBSA Digital Agriculture Initiatives and to introduce our resource speaker, may I call on Dr. Vladimir Fronda, the DAIC and ESD Director.
Thank you. Okay. Relax lang po. I can feel the tension. Okay. Congratulations to the College for Agriculture and Natural Resources for the festival for this year. Again, good afternoon to everyone. Our dear President, and the representatives, our Vice President, our faculty and students, maraming hapon po sa labos. Maraming hapon po. I was tasked by the MC to handle two topics. One is to orient you on the coverage of one of the newest center that Dr. Nateri created for the university. Hindi ko alam kung ilan ang centers that we have. But based on my scrutiny, the highest number of centers across universities in the Philippines can be found in ISU, Isabela State U. I think it's more than 40. Tayo medyo about mga 15 pala. So I was requested to orient you a little on the Digital Agriculture Innovation Center. And lastly, to have that opportunity to introduce our resource person from Australia.
Next.
Sorry, nanibago ako dito. That's the complete name of the center. Okay? Digital Agriculture and Innovation Center. Okay. Technologically, digital agriculture is almost synonymous ng mga naririnig nyo. Diba? Smart farming, smart agriculture. And this comprises of a new range of new technologies applied in agriculture. Okay. Napakalapad po ito. And in general, this is the integration of ICT to agriculture. As you can look at the technological coverage, it can include GIS, use of drones, automations and robotics, biotechnologies with LoRaWAN, okay, automatic weather monitoring, animal health monitoring, use of agricultural devices like sensors, and systems development. These are just a short list. Sila Doc Bing ay nandito, at nung araw na po nila, they are setting up very expensive sensors in the university. It is already running actually. Okay. Tayo na dyan sa mga ilang PhDs and hopefully at the end of the day, we will confirm the data. It is now being run by a company from America, coupled with the cooperation with the with groups from India. So this is just a short list of the technology that the digital agriculture can cover. You might be interested in some of this area in your field. You could contact us in the Digital Agriculture Center and we'll provide you opportunities to make use of all the facilities. Okay. Nagtanong po kahapon ang Dean ng SEF. Nandito po si Ma'am Karen. Tama ba? Wala. Okay. She asked about kasama pa sa digital agriculture po yung pyrometer. Okay. We have 3 of it. Tama ba? We have 3 of it. Then we are happy na yung pong ating isang agroforestry sa Belgium, who is taking this research in Belgium, is making use of those facilities to test the solar, anything related to solar radiation shading. Ang ating pong university is aligned to, in the next few years, to serve as agricultural research university of global standards. And po yung ating platform, at yan po yung inspiration natin. That's why we are all doing these things along digital agriculture. Magkakatalan na dito. Those are the aims of the digital agriculture. First is to harness the power of digital technology and apply it, demonstrate it, and scale it up for mainstreaming, hindi lang po sa university and even to our partner farmers. Okay? It will also explore its applications, then expose our partners, including you, little by little on the utilization of digital agriculture. Madami na pong nag-approach sa atin yung kung mayroon pala tayo dito mga business groups who are into animal production na adapting already IoT, okay? Then we put in automation so you can be, exposed to it very soon para ma-appreciate natin yung improvement of their efficiency. Okay, this is already the framework of the center. We are focusing more on creating impact. Then, this is just the initiatives of commodity coverage. Then we have the pillars of CBSUA digital agriculture facilities, having like GI, DT, and data analytics. Yan na po yung nakikita nyo dito mga facility na tinatayo. It's part already of moving towards digital agriculture. And lastly, we have the enabling environment. These are all the strategies that we have, including yung mainstreaming sa ating curriculum. We all know recently nag-propose po tayo ng ating lahat po ng ating BSc program ay nandun to the other programs. We'll have a subject on digital agriculture. That's one of the steps para ma-learn po natin kung ano po yung applications of precision farming, smart agriculture. Hindi lang para sa research nyo, kundi for your extension work and other adaptation later on. These are the facilities that we have now. Okay? And then po yan nakatago muna for distribution sa ating faculty and data centers. Isa po tayo sa may pinakamagandang data centers. Hindi pa po nag-operate, pero it's a highly technically equipped facility. Yung nandun po sa hawak po ni Sir Dan, malapit po sa ating library. Baka may picture ako dito. This is our digital center in the library. Ay doon po sa katabi ng ating library. Puno po ng servers po yan. High level, highly available servers. Meron po siyang malaking generator para hindi po siya mapapatay kahit po may power problem. Punta po ako sa ibang universities, wala po sila. Ang challenge nila, gaano natin ka-intensive magagamit ang facilities. This is our infrastructure development. We also have several drones with us. pwede nyo pong magamit sa subject ng digital agriculture. Yan pong dalawa, yan po yung tinatayo ngayon ng company nila Doc Umali. Yan po yung subflow analyzer. Okay? Nakatusok po yan sa puno ng pili tree or any tree. Or including papaya, we will also explore that one and even the planting dragon fruit to determine the water requirements of the plant.
Check. Yan.
Ikaw rin ako. Nakaliman na ako. Baka pag-anin. Wala pa rin. Ito lahat tayo. Okay ito po. Para sa may Australia. Kaya feeling side. These are example kung paano po tumatakbo yung ating artificial intelligence in detecting pili trees. Nakita yung mga pula. Kaya na po ng ating new program to detect yan by pili, new, or not pili. Meron na po tayo. Ginawa na po yan ang digital agriculture for us. Dito natin yan i-apply to other maybe other perennial trees. Pareho din ng China sa Australia. Pareho ang problema dito. Meron din po tayong greenhouse, kung wala po nakakaalam pa. It's part of our digital agriculture initiative. This is being run by CANAC and partnership also with SEPS. Nandiyan po si Engineer Claudio. Po yung crop production under a controlled environment. Ito po yung ating consultant, who is an Indian, pero ang base po nila sa Washington. They are the one doing the programming for a centralized data collection ng lahat ng IoT facilities and sensors natin. Mr. Sanjay. Inisita niya lahat na pwede po natin i-conduct yung ating research. Including, fish. Meron po tayong underwater, pwede ba naman hindi underwater camera. Underwater camera to monitor the population of fish. Image analysis po and vision analysis 1,000. Including po yung mga data natin sa in-house controlled environment. Engineer Claveria, ipapasok natin sa we are also developing our priority research area for digital agriculture. Ito po yung initial list, covering crops, trees, systems, STEM, and environment. Okay na. Ito po yung ginagawa ng digital agriculture, data management, para na po tayo weather portal. Hindi na lang po namin ito, look po yung sabi mo, yung other, iba pong automatic weather station po natin, ipapasok dito sa weather data logger and archiving. And this will be presented in public to everyone, including the students, if you need data and research information para sa inyong mga testing. We are also developing basic credit finance management. Kung research po ninyo, pwede po ninyo ipakip po yung data sa amin. We are also continuously doing trainings on data, on digital agriculture. Hindi lang po faculty, including po mga AWS, AEW, Agriculture Extension Workers. Tinitrain na po nila at ang nag-finance po niyan sa atin ay ang Agriculture Training Institute. Yun lang po. At maraming salamat. Pinulit ako na introduce ko daw sa ating resource person. Okay, our resource person is from Australia. Okay. Dumating po siya sa Pilipinas last Monday and he will be staying with us until tonight. Tomorrow po, alis din siya. Directly, I going back to Australia. Minaximize na po natin ang kanyang presence para magkaroon ng sharing with us this afternoon. He finished his bachelor's and MS forestry program at the University of the Philippines, Los Baños. He obtained PhD in the University of Adelaide, Australia in 2012. Okay. Has been with the academy for 15 years. Prior to joining his current employment, the ICT International Australia, October 2015. In the Philippines, he led several nationally funded projects in improving agricultural production systems in the country through science and technology-based approaches, primarily in the field of soil science, agronomy, and plant science in general, through the use of spectroscopy and geography and spatial information systems. So, mataas pa ang kanyang knowledge and skill level on GIS. Kanina nga, nag-discuss ang kami about artificial intelligence. At the ICT International, he integrates his knowledge in soil, plant, and environmental science in delivering science and technology-based solutions for agricultural and environmental sustainability. He has collaborated with numerous scientists from Australia, New Zealand, Germany, America, the Philippines, Vietnam, and Indonesia. In 2019, he held a secondment position at Bohol Island State University as USD College Scientist. Currently, he is in secondment at the University of South Australia in an Australian Innovation Connections Grant. So, naka-second po siya ngayon. He leads business and market development for Southeast Asia, and Pacific region, and science and training for global customers on soil plant atmosphere continuum at ICT International. Kaya po siya nandito dahil part of his function is to train global customers to support their company. Please welcome my dear students and colleagues. Please welcome our guest resource person from ICT International Australia, who is currently supporting us, CPSUA, on digital agriculture. A round of applause for Dr. BENG UMALI.
Thank you very much, Dr. Lai, for the introduction of our speaker. But before that, we would like to acknowledge the presence of our president, SUC4 President Alberto Enaberry. And may we also, as per instructed by the President, let's proceed for the lecture portion of this seminar. Thank you.
Good afternoon. Magandang hapon sa inyong lahat. So, ngiti naman tayo. Masyadong tayong seryoso. I'm actually honored to be in front of you all. This has never happened in the last 3 years because of the pandemic. So I'm happy that you are all here. Because you are all kayo ang future eh. So just by being here is a step forward para sa ating hinaharap. So I'd like also to thank yung ating organizers, headed by our university president, by our director for the Digital Agriculture and Innovation Center, all those staff, kasama yung sa ating IT division, who helped us in the last 3 days to make sure that our instrumentations here in your campus will work seamlessly. So we had a little hiccup, but at the end of the day, we were able to succeed. So at the moment, you now have one of the most powerful, I'm proud to say, na most powerful communication system sa buong Pilipinas. Okay, not. So we installed these systems to countries like Australia, the US, New Zealand. In fact, we probably are more advanced than New Zealand. Some other countries, Indonesia doesn't have this system just yet. So you should be proud of yourselves that your management, your administration is pushing for this kind of technology. So my advice to you is sit back, relax, and enjoy the ride. All right, so yung topic ko ngayon is try and give you a little bit of patutulungin ko kayo ng konti kasi medyo boring yung background science. But because you're an agriculture student, most of you are agriculture student, I would expect na meron kayong some certain level of knowledge doon sa babanggitin ko. I'll try to be as simple in my explanation as possible, but in any instances that hindi nyo maintindihan, do not hesitate to raise your hand. Let me see if this will work. Oh, it's working. Okay. There you go. So, yung title is Soil Plant Atmosphere Continuum. I'm not sure whether you've heard of the phrase soil plant and atmosphere continuum. You are probably students of soil science. You're focusing only on soil science. You dig a lot of soil samples. You pulverize a lot of soil samples. You touch a lot of soil material. You make yourselves dirty. That's it. Okay. If you're a plant scientist, a pathologist, for example, you dissect the plant. You look at the leaves. You look at the stem. You look at the roots. That's the work of a plant scientist. If your work is related to measuring the environment, you're curious about how much solar radiation there is right now, or how fast the wind is, or how dry the air is. Halimbawa, you're an engineering student and you're talking about agrometeorology, then this is what you are focusing on. So if you talk about soil, plant, and environment or atmospheric continuum, we talk about the knowledge that spans those different sciences. Okay, so if you're a plant scientist now, then you can definitely jump the bandwagon of scientists who are looking at soil, plant, and atmosphere continuum. Okay, so because of the advent of technology, we now are in the age of what we call Internet of Things technology. So Internet of Things technology is any sensor or any product that you connect to the internet. Okay? So cellphone yan, o kaya yung refrigerator nyo that can tell you whether you've run out of milk or you've run out of jam. So that's a device that is connected to the internet. Okay, so with that advancement in technology, we can use those technology to make our life easier. And for students like yourself to make agriculture more appealing. Okay, and because you're probably 17, 16, 17 years old, ang tendency nyo talaga is to hold gadgets, di ba? You want to hold gadgets. You don't want to hold the soil, you don't want to hold the plant, but there's no escaping. Wala kayong kawala doon. You have to do it, okay? But because of technology because of gadgets, you can make your life easier. Okay? So I just would like to introduce my company. That is my boss on the left. His name is Dr. Peter Carl. He finished his PhD in 1970, and he was the first person to introduce that technology on the left that is called a neutron probe. And he established a company called Irrigated Crop Technology, and that's what ICT stands for. Okay, we don't use it anymore because it's like a very archaic term, so we just use ICT International. In the last 30 years, the company developed our own system. The one on the second to the left, what we call saptometer. Okay, so it's an instrument that can measure the rate of transpiration of plants. I'm not sure whether some of you may have studied photosynthesis and how plants transpire and how to measure that. This is an instrument that can do that inside the plant. Okay, so install a sensor and then the instrument measures transpiration. The one in the middle is called the water potential sensor. It measures how stressed the plant is. Say, for example, there's a pathogen, it attacks a plant, the plant undergoes some stress. This instrument can measure that stress. Okay? If you want to know what a unit that is, you can talk to me later on. So those are two of the instruments that the company started to develop in the 90s and well into the 2000s. But because of the advent of, as I said, new technologies, we now have the ability to measure the whole soil, plant, and atmosphere continuum. So we have sensors for the soil, we have sensors for the plant, we also have sensors for the environment. And we export to 50 countries around the world. Let me also quickly, okay, tell you about our partner here in the Philippines. The company's name is Codelco, but let me skip through that. I just wanted to let you know that we are in partnership with a local company called Codelco. That's just a plug. Okay, they became a distributor in 2021. And for any local support, they'll be the first point of contact. Okay, let's now go to the boring part. Okay? An explanation of the soil, plant, and atmosphere continuum. The main objective of measuring or being able to understand the soil, plant, and atmosphere continuum is the way we track where water goes. Okay? Kung saan pumupunta yung tubig. Okay? So, from the ground, okay, meron tayong soil moisture. Okay? Meron tayong available soil moisture sa ground. The plant or the root system senses where they are. Okay? Plants have the ability to sense where they are. And when they have located where they are, usually if the plant is transpiring, water would move from the soil matrix to the roots. Okay? Meron ditong magnification ng roots. Itong, can someone put me on yung pointer? Pwede ba ilagay sa pointer para may... Ay, nandoon ba sa ano? Diba, okay na. So, ano lang to, itong nasa baba, left side is just a magnification of root structure. If you magnify the root, it's composed of the cell wall, epidermis, exodermis, cortex, epidermis, and pericycle. So, water would move from the soil through these different structures and into the stem. Okay? So, i-follow nyo itong nasa left side, ito magnification nasa right side, and then the water would move from the lower section of the plant to the middle section of the plant, and then through the leaves, and then out into the environment. Okay? So, bakit may transpiration? What is the process that the plant undergoes? Who can explain? And who can tell me the process that drives transpiration? It starts with the letter P. photosynthesis. Okay, so how does photosynthesis work? What's the major, anong kailangan ng photosynthesis to happen? Sunlight, okay? So, sunlight penetrates the leaves or shines the leaves, and in the leaf, there's an organelle, di ba? Meron dong component that can harvest the light, and that energy, yung na-harvest ng light na energy, will be used to convert what? Convert what? Starts with the letter C. Carbon dioxide. And starts with the letter H. Hydrogen. Okay, so carbon dioxide plus water. Diba? If you can imagine the process of photosynthesis, carbon dioxide plus water, you have sunlight and the equal sign, and at the other side of the equation you have C6H12O6 plus oxygen. Correct? Correct? Tulog na yata kayo eh. Okay. So that's the product of photosynthesis. Okay? So as photosynthesis happens, the plant transpire. Okay? Oxygen is released through the stomates, and along with that is also some amount of vapor. Okay? So yung pag bumukas yung stomates ng leaves, may kasamang nare-release na tubig. But of course, water is being used by the plant for carbohydrate production. Okay, so I'll try and make this quick. Kasi alas 10 na. Okay. All right. So if we really look at, if we try and this is a deeper level understanding of the soil, plant, and atmosphere continuum. There is a gradient. Okay, there's a gradient between in the energy. Okay, so sa root system, the energy that is required to move the water is about negative 0.3 megapascal. That's the one at the bottom. In the roots, okay, it's negative 0.6. In the trunk, it's negative 0.8. In the leaves, it's negative 1 megapascal. And as you go out in the air, it's negative 100 megapascal. So the more negative the unit is, the more energy is required, okay, to extract the moisture or water from the environment. Okay, so yung air natin, this is relatively dry. Walang tubig, walang masyadong tubig. There's water vapor here. You are transpiring as well. You are nagre-release kayo ng water, yung mga kilikili nyo. Okay? But basically, yung air natin has has lower water potential. Okay. Oops, sorry. All right. So now you have a little bit of an understanding of those systems. You're trying to measure those gradients. Yun ang mini-measure natin. Kailangan nating ma-measure yung moisture regime ng soil. Kailangan nating ma-measure yung water content or water regime ng plant at saka yung water regime ng environment. Okay? Now, yung different gradients na yun yung nagde-determine kung saan pupunta yung tubig. Okay? Kasi yung behavior ng any material to move from one location to another is determined by yung concentration niya, di ba? Kapag maraming concentration dito, mag-move siya doon sa lesser concentration. Di ba? So, yun yung isang factor kung paano mag-move yung ating tubig. But of course, if we look at it holistically, these are now 5 of the key factors that affect movement of water in plants. Okay? So you're well familiar with this terminology. We have humidity in the air, wind speed, because that drives where the humidity goes, okay? Temperature, because if there's temperature, your water molecules would move faster if the temperature is higher as compared to when you have a cooler environment. Solar radiation, because it drives both the temperature and wind speed. Okay, if you've studied agrometeorology, solar radiation changes the um, temperature of air. Okay, and then that basically drives where the air moves along with the humidity. Right? And in the soil, you have soil moisture and tension. So if you are a soil scientist or if you're studying soil science, these are two critical factors that you need to measure. You're always measuring soil moisture. Baka sabihin niyo palagi na lang kami nag-weigh ng soil at nag-determine ng soil moisture. Okay? But this is very important because if there's no soil moisture, there wouldn't be any material for the plant to use up for photosynthesis. Okay, so now I'm going straight into the technology. What we have are instruments that can measure all these processes. Okay, so we have instruments that can detect soil moisture, instrument that can detect water potential, soil temperature, even oxygen, and how fast water drains in the soil. Okay. So at the moment you have this system, soil moisture system. Okay, so we call it sensor node integrated package. Okay, so it's a SNP. So if you see something like this, like there's a solar panel, there's a small box with a little antenna hanging underneath it, and then there's a few wires, and it's buried on the ground, that means that's a soil SNP. Okay? So if you happen to pass by doon sa inyong pili group, there's a system there. It's just not set up properly. Pero mamaya paglabas nyo, try to pass by pili group. Doon sa may harap ng education building yata yun. Saan ba yun? Dito yata yun. Diyan. Yan. So merong SNP doon, merong ganitong system. Okay? So yun. So plant, we have sap-flow, we have dendrometry, frost and leaf wetness, canopy temperature, vegetation indices, and then light. So for sap-flow, this is, as I said earlier, this measures rate of transpiration. For the dendrometry, it measures the girth size of the stem. So it basically tells you how fast the stem grows as the plant grows. Okay? So di ba tumataba yung puno? So this sensor measures that rate. Okay? There's frost and leaf wetness. So there's a sensor that can determine how wet the leaf is. So this is important in pathogen build-up. Kasi yung mga ibang fungi, they love wet leaves, di ba? So kung gusto mong malaman kung anong relationship ng how wet the leaves are in relation to how fast the pathogen invades the plant, this is one sensor that you can use. Next is canopy temperature. You also have this system. We also can call it crop water stress index. So canopy temperature is a sensor that's just at the top of that pole. Okay? It's remotely sensing the temperature. It's just like when you're being measured for temperature during the COVID pandemic time. Meron binabaril dito sa noo natin para ma-measure yung temperature. Ganon din sa plant. Kala nyo, kayo lang ang nababaril ng infrared sensor. Yung ding mga plant, kailangan nila ng canopy, kailangan nila ng temperature measurement because I'm not sure whether you're familiar with how plants cool the environment. Because of transpiration, ang nangyayari, we have relatively humid air because of the release of water. Okay? Nagiging cooler yung place. Okay? So pagka wala nang may transpiring plant, ang tendency ng leaves is to heat up. Iinit yung surface ng leaf. So that corresponds to some level of stress. Okay, so that means if you have low moisture regime on the ground, your plants will start to wilt, and the corresponding temperature of the leaves will be higher as compared to when it is happily transpiring. Okay? Vegetation indices in remote sensing, this is very much used. There are certain parameters that you can use in terms of the spectral signature of the leaves para ma-determine mo rin yung health status. Okay? Last is yung light. Okay, so there's light sensor because there's a certain bandwidth within the light spectrum that the plant can only use. It's called photosynthetically active radiation. So it's between 400 to about 700 nanometer, if I'm not mistaken. So yun yung visible light, within the visible light. So the reason why the leaves are green is because it's basically reflecting the green spectrum of the light. Okay, so it's using actually just the red, some of the red, majority of the red, and some of the blue light. Okay, so we have these sensors. Okay, all of these sensors can be connected to a node or a logger, and then that logger pushes that data to the cloud. Okay, in terms of climate or environment, we have weather station, microclimate, rainfall, light, and then again light and air quality. Okay, so you have weather station with rainfall and light. Okay, so that's what you have. So kung mapapadpad kayo dun sa organic garden, there's a system that was just temporarily set up there. It will be up there until this afternoon. We will take them down for security reason. But you have this weather station with rainfall and light. But if you pass by dun sa Pag-asa weather station, you can also try and check what sensors they have by just looking at that station. Okay. Okay, so this is not important, but for sensors, it needs to be able to communicate to a device that will pick up the signal. Okay, so these are just some information that tells you about what output the sensor is giving you, and so that's why I put this up, but these are not important for you guys. Some of you might be curious kung ano yung mga ito. You can look at our website, they're all there. Crucial lang dito is when you are trying to connect, I'll try and go back here. So alam mo dapat yung output, alam mo dapat yung connectivity, okay? It can be either through LoRaWAN, NB-IoT, or through satellite. Okay? You have an existing LoRaWAN system here, so that's all good. And then yung format ng data, is it open format or is it a closed format? So what you have is an open format, meaning you can read the information so long as you have access to the data. Okay, so that's that. And then power system, the reason why the system has a solar panel, so that yung measurement mo won't be interrupted. Okay. The sensor needs to have a power source. Kailangan nila ng energy para sila yung measure continuously at magbato ng data sa cloud or sa internet, similar to how your phone works. So you have to have power system. So what your system has is a built-in lithium-ion battery, but it's supported by a solar panel. And then yung environmental security niya in terms of water ingress. Dapat hindi siya papasok kasi mga electronics ito. So you're talking about electronic systems. So say for example, that one. So that's what the node looks like when you open it up. So there's a board. Okay, so there are electronic components similar to what you can find in your computer or in your devices that you're holding now. ganyan ang itsura sa loob. So dapat dry siya palagi. Okay? Para maging dry siya, dapat meron kang sealant. Okay? Okay, so this is an example of an IoT node for environmental monitoring. We call it MFR node. So this is not important, but just to let you know, there are different kinds of nodes that can accommodate different types of sensors and can output different kinds of sensor output. Okay, so this is one kind. In fact, you have this system, you have an MFR node, you also have an S node. Okay, hindi na ito masyadong makalagay sa inyo. If my clicker will work, this is another one, an AD node, not very important. But if you want to have a look at the whole range of our products, it's in our catalog on our website. Okay, I just wanted to quickly give you an illustration of what a system would look like out in the field. So this is an illustration of this is an oil pump. So we have an oil pump in the middle. We are measuring sap flow using sap flow meter at the middle. And then on the left side, we have air temperature and relative humidity. And then we also have soil moisture on the ground that measures the soil as well as the environment. And on the right side, we have rain gauge. And at the bottom, we also have a lysimeter. Okay? So if you're simultaneously measuring all of these parameters, or if you're gathering information from all of these sensors, then you can, marami kang pwedeng information na ma-derive. Okay? So while you're trying to measure transpiration in the plant, you are trying to measure amount of sunlight. Ibig sabihin, kapag na-measure mo yung amount ng sunlight, and this is how much transpiration the plant is exhibiting, then, for example, at a lower light regime, ganito yung kanyang water usage or transpiration, then meron kang baseline information. And then the more information you gather as you progress with your measurement, the more knowledge you gain out of the system. So another system here, we have a rain gauge and a leaf wetness sensor on the right side and an ATH. This is under a canopy. And then on the left side, we have fuel moisture sensor. We have a rain gauge, soil moisture. Right? This is an example of one of the first systems we've established in the Philippines. This is in Bataan, a project we have with Bataan Peninsula State University in 2019. And this was deployed during the pandemic in 2020. So this is the dashboard. This is a portal. Okay? It's called Eagle.io. We partnered with Eagle.io to bring up this dashboard. But basically, the project is funded by the Department of Science and Technology and the Bataan Peninsula State University. They have a weather station, but they also have sensors installed on the ground and on the plant. So I won't be able to show you the data right now kasi hindi maganda yung dashboard. Pero I think merong certain examples. So this is where it is. It's in the Bataan Peninsula. I'm not sure whether you know your Philippine geography. This is on the western side of the Philippines. On the right side is Manila. Nandito yung Bataan Peninsula. Nandun yung farm, yung kung saan yung may yellow pin. Okay, so it's located in a private farm owned by a private person, but the project is being spearheaded by the university, and that's the sensor, similar to what you have, a dendrometer and a sap flow meter. That's a node in the middle, on the left side of that middle image, but you have solar panels on the ground as well. So you have persons who are installing the sensors on the mango tree, and then you have nodes on the ground and on the side of the tree. That's a weather station on the right side near the mango orchard. So that's how the system looks like. So you will further down the track in a few weeks' time or in a month's time, you will see setup similar to this one. Okay? So if you want to be part of taking care of this instrumentation, that would deliver you data. Okay? Make sure na hindi siya mananakaw, alagaan niyo siya. Kapag ka natumba yung solar panel, i-alert niyo si Dr. Vladimir Foronda, medyo na kailangan po ng adjustment yung inyong solar panel, etc. etc. Para meron kayong magamit sa inyong pag-aaral. Okay? So ito yung tsura ng dashboard. Simple dashboard lang. This one tells you, I think this is soil moisture and stem diameter or stem circumference and soil temperature. Okay, so this is a 7-day historical, this is more than 7 days. Okay, so this is relative humidity on the left side, air temperature on the right side. This is local environmental data. Okay? So, di ba, pag naggagawa kayo ng thesis, kukuha kayo ng data sa pag-asa, pero hindi siya masyadong related dun sa study side nyo. This time, you will have this data, you will have the ability to get this data locally, especially if your study site is within the sites where we put up these sensors. So you just talk to Dr. Foronda, ask where you can establish your own site, where these sensors or where these weather stations are located. Okay, so as an output, that project in Bataan Peninsula, they were able to present a poster in the International Drought Act Convention in Brisbane, Australia. Okay, so ito yung poster nila. They were also able to generate information for the growers. Okay, so yung mango grower nila was able to determine how much water the tree would require during production period. Okay, so crucial sa plant, dun sa kanyang mango tree, that there should be more than 100 liters of water available for the plant because that's how much the plant is using per day. It's using 100 liters of water per day. Okay? Kayo, iinom lang kayo ng 2 liters a day, di ba? Sometimes even more. But a huge tree, similar to what we saw, or similar to what this image is showing, it can use up to about 100 liters of water. So you might ask, how much would a pili tree require in order for it to produce 1 pili nut? So those are the questions that you might be able to answer when you use this information, when you use this system. Okay? So it now boils down to more information. Okay? Kung hindi kayo nagtataka kung gaano kadaming litro ng tubig yung ginagamit ng halaman nyo, I suggest you start thinking about it, especially if you're an agriculturist. Okay? Because it will become very important in the future, especially in the advent of climate change and abrupt weather patterns. Okay. So ngayon ang Pilipinas nag-uumpisa ng mag-ising, nagbabago na yung ating rainfall patterns, hindi na umuulan doon sa mga lugar na umuulan dati, ngayon umuulan naman doon sa hindi dati umuulan. Okay? So kailangan malaman natin kung anong mangyayari dun sa mga halaman kapag nabawasan yung mga ulan. So this is an example that I was instrumental in Australia. This is a sandalwood tree. I'm not sure whether you guys are familiar with what sandalwood is. Sino nakakalam po yung sandalwood? Yung ginagawang pamaypay na mabango pagka pinaypay mo? Hindi nga na. Okay. Anyway, it's a commercially important tree. So they harvest the trunk, and then either they extract the oil because it has an oil for perfume vehicle. So ginagamit siya as a vehicle for perfumery, and also the wood is being used as pwedeng abaniko o kaya pwedeng jewelry box. But in Australia, because Australia is the driest continent on Earth, they need to manage water resources very carefully. So if they establish plantations like this in Australia, they need to be able to measure exactly how much the tree would utilize. Okay, so ginamit yung instrumento na yan to measure sap velocity. In Vietnam, this is in Dakla for coffee. We did a small experiment showing how much water the plant would use if we remove if we cover the soil with plastic so that rainfall will not seep through the roots, okay, or seep through the soil. So may plastic dito kasi minimeasure na tinakpan natin yung ground, okay, para malaman natin kung yung coffee tree will be affected by the reduction of rainfall. So I think, so dun sa uncovered, it's getting, ang peak nun ay nasa 80 liters per day. Wala akong pointer there. Yung nasa taas na yun is about 80, but dito sa baba, it's only about 60 liters per day. This is covered, the one that is covered is only using up to 60 liters. Kasi yun lang yung available dun sa plant eh. Hindi niya nakukuha yung available doon sa uncovered tree. Okay. So if you know for a fact that the tree will be utilizing 90 liters or 80 liters of water per day, then that's how much you should put. Okay, even more. Kasi yung iba nag-infiltrate, yung iba nag-evaporate. Okay. So kung lalagyan mo lang siya ng 70 liters per day, that means hindi enough yung water. No? Ayun. Okay, so this is almond tree. I'm not sure whether you've tried almond before. So yung almond, ginagawang almond milk dun sa mga lactose intolerant. Okay, so this is a primary product in Australia. Almonds is a primary product in Australia. So, and of course, again, this is being grown in a dry environment. They need to measure how much the plant is actually using. So, on a good day, it can take up to 123 liters a day. But on a bad day, it can only use up to 40 liters a day. So there are factors that can contribute to this discrepancy. Okay, so if you are able to measure, rainfall, humidity, and all those different environmental parameters, you can explain why this is happening. Okay, so this is in Uganda. This is a scientist from World Agroforestry Center, but he did his PhD as well in Adelaide, South Australia. So he's measuring sunflow of trees that are interplanted with coffee. Okay? So it's an agroforestry trees. Sino dito yung agroforestry students? So this is where your knowledge can also come in. So this is just a publication. This is in Indonesia. So we measured palm oil, but this palm oil doesn't have a main stem. Or meron siyang main stem, kaya lang mahirap siyang installan ng sensor. So what we did is to install sensors on every frond. Okay, so you can also do that just to see if there's any gradient or any differences between in each fronds. And we found out that the younger frond can use up more than the older frond at the bottom of the palm. So yun yung isa sa naging output namin. Macadamia, this is also another output. We have water usage during flowering stage. So this is in relation to the rest of the phenological stage of the plant. Okay, in phenological stage, when it is starting to bud, when it's starting to burst the leaves, and then when it starts to generate, mature leaves, and when it starts to flower, and when the flower starts to mature, okay, and becomes fruit. Okay, so they found out that during flowering stage, macadamia can use up to about 65 liters of water as compared to when it's not flowering, to only about 40 to 50 liters a day. So, pag nagbulaklak yung halaman, kailangan ng tubig ng mga halaman. This is in vineyard, so this is a grapevine. Okay, so this is just different experimental design. So different results as well. So different behavior of water usage depending on depending on the amount of irrigation that is applied. Water potential, binabag na ako. Okay? As I said, this tells you or this allows you to measure the stress condition. This is not part of your system or of our installations here. But if you're interested to know more about this instrument, just let me know. But we've also partnered with a dashboard solution. So this is a company based out in Australia. We call Eratos, and they have the capability for inputting or pulling all data together and then come up with a decision tool, for example. So in-introduce ko lang, but essentially we have a partnership with them, and the idea is similar to what Smart Hub AI or what you will have here, which is Infer. Meron din kami solution for that. Okay, so I think I've gone over time. Not sure whether tulog na lahat. Okay, mabuti naman. But I hope I was able to relay some knowledge to you guys. And hopefully, mas mahalaga doon ay na-encourage ko kayo na mag-aral ng inyong natahak na kurso sa agriculture. Kasi importante ang agriculture. So, keep studying agriculture because we are a dying breed. So I hope you guys are motivated with the system that you have, yung inyong pong digital agriculture systems dito sa inyong university. And do not hesitate to contact Dr. Foronda sa inyong mga research. Kasi kailangan ni Dr. Foronda ng mga bright minds, enthusiastic minds, at saka yung masisipag. Okay? Kasi kailangan ng tulong ni Dr. Foronda. With all of these technologies, Dr. Foronda is only one person and he needs you guys. Okay? So with that, if you don't have any question, I'm happy to let you go.
Very much, Dr. BENG UMALI, for the very comprehensive presentation you've shared to us about the benefits, advantages, and uses of the AI in agriculture, and also for giving us review of the botanist side for the students, how plants function, what they look like, how they are related to each other, where they grow, how people make use of plants, and how plants evolve using now the artificial intelligence. And of course, we are delighted, not just the young ones, but the professionals, the professors that present here today. So thank you very much, Bob. So before the awarding of the certificate, may I let's proceed for the open forum first. If there are some questions or clarifications that would like that the students and the faculty would like to raise, we do have okay, sir.
Good afternoon, everybody. Good afternoon, sir. Sir, doon po sa system na yun, hindi po ba harmful yan sa mga, for example, sa agriculture, yung mga stainless steel? Kasi yung gadget po pa nilalagay sa trees, may certain high frequency po yan to gather data. Di po ba sensor, di po ba? Pero po yung electronic, hindi ba yan nakakasira ng sensor ng mga beams? And meron na rin po bang system yung sa system ninyo na monitor niya, yung pollen na madami na, pwede na siyang transfer yung another pollen into the other.
So you're talking about bees
Yes.
and pollen production?
Yeah.
Okay, sige. So yung question mo about whether or not the instruments will be harmful to wildlife, because of the low band frequency of the device, wala akong scientific evidence pero you've been using mobile phones, which has higher frequency bands. Yung devices na ginagamit natin dito is very low. It's it's basically 800 megahertz or less than 1 gigahertz. So it's very low power. Ibig nang sabihin ng LoRaWAN is long range, low power, wide area network. And so ang assumption natin dito is it has little damage or little interference to other systems. Okay. Kung ang tanong niya naman is kung ma-harm yung tree, kung lalagyan natin siya ng sensors, yung subflow meter natin, you're only going to drill only 1.7 millimeter of hole. Okay, 3 holes yun, bubutasan mo yung puno, pero ang equivalent naman ng maliit na wood para sa puno, pero ang equivalent naman nun is yung knowledge na mabibigay ng puno sa atin kapag na-measure natin yung rate ng transpiration niya. So, may konting, siguro, sabihin niyo na sugatan yung puno, pero I don't know how many of you don't even think about, the health of the plant. Do you really care about, marami pa sa ating careful kapag meron tayong naapakang seedlings, naapakang wildlings, for example. But for the love of science, we are using sensors for us to gain more insights about plant health, about how we can take care of them properly. Because if we know how much water they are using, that's how much we're gonna give them. And so it's like giving what the plant requires. So maraming nadidehydrate na plant dito sa campus, nakikita ko, because they are in pots, walang nagdidilig. Mabuti yung mga ibang plants, they're planted on the ground, they can happily use up moisture from the ground. But I can see potted plants that are getting desiccated. So I think mas pasintabi po sa ground maintenance. We can, I don't know. And then, ano po yung last question about the bees, about pollen production?
Yeah, pwede din po ba yan ma-adapt ng for example, sa apiculture?
Sa apiculture, meron po kaming product.
Sensor niya na, for example, sir, meron po ang table na 100, so syempre malalayo yan.
Yes.
So from there, sa data,
Okay.
this table
Yes.
99, kulang
Yes.
ng mother bee. Queen bee.
Okay.
Wala siyang prinsip para
Sige.
magdami yung
Yep.
Bakit? Nade-detect niya
Okay.
na mahina ang production ng table 99 yan.
Okay, sige po. Meron po kaming product, ang tawag po ay beehive meter. Okay, so the beehive meter allows you to measure the weight of the beehive. Kasi kapag meron kang pollen production, nadadagdagan yung weight ng beehive mo. And then the beehive meter also has a built-in sensor sa loob. It measures the temperature of the beehive because temperature is very crucial for bees. Pag masyadong mainit yung bee, kasi di ba meron tayong may vent yung beehive, di ba? Kaya may vent yun kasi kailangan natin i-regulate yung temperature and relative humidity dun sa loob ng beehive. So yung sensor namin, which is called beehive meter, has a temperature and relative humidity sensor. It has a weighing lysimeter or weighing scale. It tells you yung incremental build-up ng pollen or ng honey doon sa yung beehive. Okay, so kung gusto niyo po yun, talk to Dr. Coronda. We can put a node. We can put them on a node, and then it will push data to your system.
Thank you very much.
Magandang question yun, sir.
And
I like it.
welcome to Serious Lady.
Oh, thank you very much.
Good afternoon, sir. I'm Mr. Nadeo po.
Sir.
Maganda po yung system, pero may tanong pa po, sir, yung how about the challenges and limitation of the system.
Okay, challenges. One challenge that we were able to straight away see is the security. Okay, that's why I told you at the end of my presentation that you guys have the responsibility to make the system secure. Okay, so and deploy ang university ng mga sensors and gadgets, please take part in the upkeep of the sensors and security of the sensor. Kasi namumblema kami for the past 3 days. Paano kung mawala? Hindi namin maiwanan yung sensor doon sa field kasi ang problema daw din sa campus is because it's an open campus, people come and go. Ang problema is people can just grab stuff and then go away. So, kung kayo ay concerned sa inyong university, the university has invested millions and millions of pesos for this infrastructure for your use, then I think you have to give back a little bit na mag-secure ng instrumento. Okay, so yun lang naman. So yun yung isang, sorry, naka-challenge ako. Hindi yata dapat sa akin nang gagaling yun. But other challenges are like yung technical know-how, okay? With the development of technology, we advance our knowledge. Some small details, like for example, making sure that there's a seamless pathway between the sensor and where it's going to, the data is where it's going to go. Kahapon kasi medyo 2 days ago, hindi namin mapalusot yung data galing sa sensor papunta doon sa dashboard na aming kini-create. Meron pala kaming isang nakalimutan na parameter or isang issue na hindi namin na-solve, which is allowing university IP address to get through the system. So with that, na-solve namin yung problema. Ibig sabihin, merong mga technological hurdles. Another technological hurdle we found is yung power interruption sa university. So yung periodic, inconsistent power system sa university because of kasurek ko. Ay, baka may taga-kasurek dito. Biglang nawala ng kuryente, nawala ng internet yung university, hindi namin ma-check kung okay ba yung communication ng system. So those are some of the challenges that we face. But basically, other challenges would be, the integrity of the sensor, kung hanggang kailan ba yung lifespan ng sensor, if you are making sure that it is still measuring the right value or obtaining the right value. So you need to have some knowledge about the technology itself. So say, for example, your cell phone. For example, that your cell phone can only last for about how many years? You replace them, right? Papalitan mo yan, nasawa ka na, o kaya hindi na siya, mabagal na. Gumagapang na yung pag-browse mo sa internet, o kaya pag-reply mo sa Facebook, Messenger, hindi na makago yung iyong selfie sa iyong friend. Okay, so, yun, isa yan. So, mabilis kasi yung changes sa technology. So, I don't know how this system will last, but we're looking at 5, 7, 8, 9, 10 years. So long as you ensure the security of the devices and you ensure the integrity of the devices, then I think you're up for creating a huge set of database. So yun. Ano ba? Ano naisip ko? I think yun lang muna kasi baka sabihin naman ni Sir Vladimir, may challenges pala yan, sir, huwag na natin ituloy. Hindi. I think there's always a component of human in all the things that we're doing here. So you have to understand that this is a piece of device, that this is a piece of instrumentation that requires attention, okay? Attention ng tao, okay? Hindi sasabihin Internet of Things or automated system, papabayaan mo na. Okay? Doesn't mean that. Okay? It will always have to have human intervention. Okay? Okay, good questions. Ma'am, go for it. Sorry, napalakas yung boses ko.
Good afternoon, Dr. BENG UMALI.
Good afternoon, ma'am.
I am Ami Nicolas from the College of Agriculture and Natural Resources. Mine is not a question, but sort of a request.
Sure.
Any question?
Pwede na.
In the university, sir, we have the Regional Agriculture Center, and also stainless steel is considered as our flagship commodity. And so, being such, we are expected to do more researches on stainless steel and other base as well that could help the community.
Yes.
So my question, a request and a question. My question is, Sir Vlad, especially to Sir Vlad, are we considering of purchasing the
Behind me.
beehive meter? We are in dire need of that, sir. If we would like to have advanced researches on bees, on stainless bees, we really need that, sir. As in. So we would like to request that the university, through the director of the Digital Agriculture and Innovation Center, consider purchasing one. Kahit isa lang muna po. For CBS-UA. That's all. Thank you very much.
Oh, ang sabi ko sa'yo, huwag ka masyado magpupungan. Pupungan lang iba.
Sorry.
Anyway, we are almost ending the phase 1 of the project, and we are opening for the phase 2. It's nice to mention that, and we will place it in our list. Yun lang po muna, hindi siya na pwede natin. Maybe one set of that beehive meter. Tapos naman sa. Kahit hindi na po. In fact, yung pong ating, nasa lista pa lang wish list. At least it's in the list. Lalagay na po natin sa wish list. We are looking at also possibility as part of digital agriculture and innovation to revive our soil and water lab. Okay? Also for the sino taas nga naman ng mga soils? Yung soils pa din.
They're so
Nalagay na po namin sa wishlist yan para dahil katulad po nitong mga sinabi ni Dr. Umali, last year wishlist na po yan. Last year. Now it's already in reality. Tinitest na po nila lahat na nandito at lahat po na nag-deliver yan, hindi na po nila ibabalik sa Australia. Thank you very much.
Okay lang sa akin yun.
And ito po ay, especially for the faculty, this is a long-term data gathering. Well, initially, napaka-long-term. So, with that long-term data, isa po sa challenge din po natin yung ating efficient use of the data. The form of research, the form of publication and everything. Not only to promote you, but also to promote the university. Because based on the list that we have in the Philippines, tayo na po may pinakamadaming device so far. Correct.
Kayo lang po yung merong LoRaWAN gateway na ganyan ng feature na connected straight to the internet. Ang Bataan Peninsula is through cellular connectivity. So yung sa inyo po ay mas powerful kaysa sa Bataan Peninsula. Papakita ko ng Bataan Peninsula State University.
Sa Philippines po, tatlo lang ang partner nila. In Southeast Asia, sa Philippines pa lang may installation ng telecom.
Meron po sa Vietnam, but it's not as extensive as this one.
And we hope to take the lead to that. And ang gusto natin mangyari is to talk with Bataan Peninsula. And then the other is to come up with a joint, joint research, both of faculty and the students. So yung mga bago pa lang na students, third year or second year, you might look at this one as your research opportunity na long term.
Yes.
Dahil itong data gathering po nito, pwede per minute kumukuha po yun ng data. Per minute. In 1 year or even in 2 years, in only 1 tree. Okay? Ayun, may nakita kami, the event of El Nino. So ano magiging behavior ng pili tree ngayon in the event of El Nino? Paano naman natin sa masasabing may El Nino yan? Of course, katabi po ng pili tree mo, may automatic weather station po na katabi. Then it will give you round-the-clock temperature, round-the-clock moisture, round-the-clock and everything. They correlated across the years and months. So now you already have your research. Diba? Just analyzing the data. Okay. So, ang isa sa challenge talaga natin yung utilization. So, sa ngayon, ang plano pa lang natin, yung napokolect na data po, ilalagay po na dito sa data center. Okay. Yung pinakita po kanina. We have a very good data center actually. Di pa natin binubuksan. Diyan na muna. Pero what we dream of in the next maybe 1 year, nasa labas na po yan. So sabihin, nagre-research ka po dito, pero nakikita mo po sa laptop kung anong nangyayari by minute. Doon sa iyong sample na nandun sa military, nandun sa dragon fruit, nandun sa all crops na pwede applicable po yung ating devices. Pwede nyo pong i-request at gawin nyo. But, of course, the security really is critically necessary. Pagtulungan po natin na yan ay hindi mawala at mapangalagaan at yung data ay magamit po ninyo. So yan yung po dream natin. Hindi lang po hanggang yan sa data center. And pag sinabi ko po sa data center, makikita nyo lang ang data, nandito kayo. Hopefully, makakuha po kami ng solution na anytime nasa nakaunan. Ano po, at yung inyong professor at yung inyong student researcher, makikita din. Dahil hindi po kayo lahat makakakita to inform everyone. Yung kung teacher nyo na kaalay nyo, ano po, kapartner nyo sa research, i-authorize kayo makita ang data. So kayong dalawa makakita. Kung i-authorize ang kapartner na isang research, 10 kayo in one research, so kayo 11 makakakita ng data. Yun lang ang restriction. Yung iba, hindi nyo pa naman kailangan. So yun yung muna initial restrictions natin. Ano po, to just ensure that the data are well secured, ano po, at magagamit po ninyo. After this po, maybe in the next 1 to 2 years, yung data po yan, ipupan po natin, i-utilize natin yan for automation and robotics. So sabihin, kung kayo po engineering, you are thinking of what is the irrigation requirement graph on alas 7, alas 8, alas 9. Using the data in the past with the necessary temperature, pwede nyo na pong gawin na i-automate ang irrigation. This only much of volume ang i-release ng systems nyo. Pag gabi, wala. That kind of automation is very feasible using the collective data. Yan po yung sunod natin scale. Kaya po data collection in analytics, then maybe in a year or two, we go forward to automation. Yun lang po. Thank you very much. Sige ma,
Beehive in the future. But aside from Beehive, you can also, if I may add, if your bees are dependent on a particular plant species for pollen sources, I think it's also important for you to measure the pollens or the plant health of the pollens where your bees are getting the pollens from. So, meron po akong tinutulungan scientist sa Western Australia na bee producer po siya sa Western Australia. Measure niya yung mga water usage ng mga trees kung saan nagko-collect ng bees, nagko-collect ng pollens yung bees. So if you know for a fact that these bees are dependent on, say for example, pili pollens or pili flowers, then you can look at, say for example, production with regards to water usage of the trees within the vicinity. Or say for example, ano bang pollen, saan po yung pollen source ng inyong stingless bees?
One is coconut.
Coconut, o yun. So pwede rin pong yung coconut i-measure natin for water usage. So malaking, malaking may relationship po yung health ng trees, ng where your bees are collecting pollens from in terms of bee production, pollen production. So, yun po yung isang naalala ko lang na project ng isang scientist from Western Australia. So, basically, whatever sensor data that we have from our sensors at the moment, most likely you will be able to use that for your pollen research later on, or your bee production research later on. Yeah. Magandang question po yun. Thank you. So, who else? Oh, yes, ma'am. Go for it.
Sir, good afternoon po. Ask ko lang po kung may technology po ba kayo na nagsusukat or nakakapag-detect ng age ng isang trees po?
Age ng trees. Meron tayong core sampler. Pero dendrochronology kasi yun eh. So, hindi kami yan nagtitinda, but I can point you to a person or an organization that can look at that product. Yun. Yun ang sagot ko. Yes, sir.
Ilay na doon sa tanong, bigla ako dahil may mga activity din silang ganyan. Ito kasi gusto din natin yung mga gamit natin, maging gamit na din sa laboratory at the same time, di ba? Ang hirap naman kung palagi na lang tayo kitang sa carbon. Di ba? Oo. Yung bang studento mo across any species?
I think so, sir. Meron lang konting calibration na gagawin. So, meron din tayong tinatawag na, we do have a product. It's called a resistograph. So, it tells you kung gano'ng ka-strong yung wood, live or dead. Okay, but it can also provide you cross-sectional profile of yung rings. Okay, kasi as the tree grows, di ba may ring siya. Yung rings is related to 1 year, 2nd year, 3rd year, 4th year. So yung density ng ring na yon, it varies. Merong higher density, merong less dense na section ng ring na yon. So yung instrument na yun, which is called the resistograph, you can use that to measure the age of the tree. It's semi-destructive, but I think the tree wouldn't mind. Mag-train din siya, mag-train siya sa puno.
Baka maganda rin kwento mo, sir, aside from the sensors,
Yes.
you will also be delivering some handheld facilities.
Yes. So aside from these sensors, we have handheld instrumentations. Dr. Furonda, your university has acquired a photosynthesis machine. Okay, so if I'm not mistaken, there are only 3 devices around the Philippines with that particular nakatulad nun. Okay, it's a photosynthesis machine. So photosynthesis can be measured in 2 ways. You can measure it by light or by a gas exchange. Okay? So di ba yung dun sa process ng photosynthesis, merong exchange ng carbon dioxide with oxygen. So yung gas exchange, it measures available carbon dioxide in the leaf. So may cuvette siya. Cuvette is a clamp. Okay? Merong i-measure ng instrument kung gaano kadami yung concentration ng carbon dioxide initially. And then yung leaf na yon magta-transpire, okay, if it's out in the sun. And then the instrument will measure again at a certain point in time what is the change in carbon dioxide content of that chamber. Okay? So the rate of change is related to the photosynthesis rate. So that's what gas exchange system is. That is what you have. It uses infrared gas analysis to look at the gradients of carbon dioxide in the chamber, in the leaf chamber. So meron po kayo nun. So if you want to obtain baseline data of your plants, say for example, you're measuring, I don't know, pili, corn, papaya, talong, okra, maganda meron kayong information about the photosynthesis rate of your plant. So halimbawa, gusto nyo, nasa ano kayo, nasa soil science kayo, gusto nyo malaman kung ano yung effect ng fertilizer regime or additional fertilizer, o kaya nag-evaluate kayo ng organic fertilizer, for example. Meron kayong control, meron kayong additional organic matter, meron kayong additional kung ano man, mulch plus organic matter. Titignan nyo ngayon yung photosynthesis rate ng bawat plants nila. So you can use the device to measure the photosynthesis rate, whether there is difference between your treatments. Okay? So yun yung isang device. So, ulitin nyo si Dr. Foronda. Sabihin nyo kay Dr. Foronda, Sir, kailangan kong measure ng photosynthesis ng aming pong talong. Kasi ganito po yung objective ng aking research. Gusto ko pong malaman kung ano nangyayari sa plant, if there's any improvement in the health and in the way the plant is photosynthesizing, then use the photosynthesis machine. Another device that you have is what we call canopy imager. So a canopy imager uses a hemispherical camera. It's a handheld device. It has a touch screen. Yung device, meron ba tayo mamaya? I-demonstrate ko na lang. It's like a gun, basically. So hawakan mo siya, babarilin mo, yung hemispherical camera nandun sa dulo ng iyong sensor, ng iyong machine. Tapos kukuha siya ng image. Okay? Nakatingin pataas yung camera, ang tawag sa kanya hemispherical camera, may parang dome siya, parang CCTV camera din, may dome. Pero nakatingala siyang ganyan. Okay? So makukuha niya yung canopy. Kaya ang tawag sa kanya canopy imager. I-image niya yung canopy looking up. So it's like, you're like that, yung canopy nandito, kukunan niya ng litrato yun. Pag nakunan niya ng litrato yun, i-analyze niya yung image, ibibigay niya sa iyo yung leaf area index. Who is familiar with leaf area index? Yun, meron kayong device na gano'n. So if you want, for example, to measure any canopy, halimbawa, how your talong grows, pwede mong i-measure incrementally yung canopy development ng inyong crop. Okay? So halimbawa, gusto mo na namang malaman yung, ano naman tayo, sa pathology naman tayo, kasi may mga plant pathologists dito eh. Halimbawa, nag-introduce ka ng, nag-inoculate ka ng pathogen sa plant mo. So meron kang growing plant, nag-introduce ka ng pathogen. Bago mo introduce yung pathogen, meron kang baseline data about the canopy. In-introduce mo si pathogen, titignan mo kung anong mangyayari dun sa plant mo. Ang isang magandang measure is yung leaf area index. How fast the leaves will shrink or defoliate kapag in-introduce mo yung pathogen. Meron ba kayong ganong studies? Nag-introduce ng pathogen sa plants? Yun. So, gamitan nyo ng canopy. Dito pala yung mga plant pathologists. Hindi pala dito. Yun. So, yun. O kaya, meron kayong sa entomology. Nasaan yung entomologies? Yan. Pag merong herbivory. Diba? Herbivory yung kakainin yung dahon. So, if you want to measure yung herbivory rate, meron kayong tinatawag na leaf area meter. So, you have a device wherein you can scan the leaf. It tells you the square centimeter area of the leaf. So, halimbawa, meron kang baseline information, halimbawa, ng okra mo, i-measure mo yung leaf area niya, scan mo lang yung leaf, introduce mo si grasshopper, o kaya si beetle, o kaya ano naman ang insect na gusto mong ilagay sa iyong plant. I-measure mo ulit after herbivory time. Okay? So yun, meron kang initial plus after herbivory. So, mami-measure mo ngayon kung gano'ng kabilis kumain yung inyong mga insekto. So you have a leaf area meter, you have a canopy imager for trees, and also for pwede rin yung mga row crops. Okay? The other sensor that you have is a soil moisture probe, mobile soil moisture probe, yung MP406 kit. Okay? So it's, merong mobile device na kasama yun, may cellphone na kasama yun. Ito-turn on mo lang yung app, turn on mo yung transmitter, and then ito-turn on mo yung, ito-turn on mo yung app, ito-turn on mo yung transmitter, pag-connect mo yung device, and then you can just initiate measurement. You push the soil moisture probe on the ground, and it will tell you the volumetric soil moisture content of your soil. So yung mga soil science, nasan yung soil science majors dyan? Yun. Gagamitin niyo yun. Soil moisture probe. Okay? Ilan pa meron kayo ng soil? Isa, dalawa. Hindi ko maalala. Basta meron kayong mobile soil moisture probe. So if you're measuring, for example, your potted plants, you want to measure soil moisture of your potted plants, or even yung mga rows na diniligan nyo, halimbawa, you can use the soil moisture probes as a mobile device. So meron kayo nun. So yun yung 4 major instrumentation that you have. You can use out in the field and in the lab. Kasi pwede nyo gamitin yung leaf aerometer sa lab, tsaka yung soil moisture probe. Yung canopy imager, sa panglabas yun. Yung photosynthesis device, you can also use that in the lab. So kung meron kayong samples ng plants that you want to measure, you can use that system in the lab or in the greenhouse. Okay, so any other university who has that combination of sensors? I don't think so. Kasi kayo pa lang yung nakabili ng sa amin na ganun ka expansive yung mga sensors. So you don't only have these IoT devices out in the field, you also have supporting instrumentation for field measurements. So kung hindi abot ng sensor natin kasi nakafix siya sa ground, you can bring these devices for measurements out in the field. Hindi ko pala nabanggit yun sa inyo. So thank you for letting me tell them as well. Okay, so excited na ba kayong lahat? Yes! Dapat lang. Kasi yes ma'am, meron pa questions ma'am? May time pa ba tayo, sir?
Of course, wala na. Pero sige.
Thank you po. Good afternoon, sir. Magtatanong lang po if you have device on the methane emission on rice.
Wala po kami methane emission. Hopefully in the future, we are collaborating with a manufacturer from the US who has that. Pero kung meron kayong, usually kasi yan, meron ako kilala from Europe, but we don't represent them. I can let you know kung sino sila later on. Harapin po ako dun sa tabi. Any other question? Wala na, sir? Ay, ma'am. Okay. Katapit muna ako dito para nahihilo na ako.
Good afternoon po. Malias ko lang din, sir. Do you have any device or machines or technology na can measure plant growth regulators or hormones, specifically the ethylene level or acetic acid?
Ako. Meron po tayong ethylene analyzer. Pero wala pa po ngayon.
Yes, sir.
Sir, sorry. Yeah, challenge dito. You have research activities, you have research goals. I think you need to pattern what Dr. Vladimir did. Write the proposal, look for funding agencies, and make sure na mabibili niyo yung mga gadgets na yun. So we have ethylene analyzers, pero yun primarily for fruit. Doon ba kayo sa post-harvest pa kayo? Okay. Tamang-tama po yung ethylene analyzer. We also have sensors that can look at fruit quality. So using infrared analysis. Near-infrared analysis, NIR. So, yes ma'am, please talk to us.
How about, sir, yung other, di ba, GAs?
Ano po yun?
Gibberellic acid.
Wala po. Wala po.
Thank you po.
Okay. Sorry, sir. Marami po akong binibenta. Sales pa ang dating.
For the faculty, ito lang po yung remind ko na mas maganda if we start building our ideas on research. Then if we have windows for accessing funding, we'll do that. But we can place everything, yung kanyang mga interest, then pwede na natin yung ilagay. Pero ang suggestion po namin, huwag na po natin gawin yung nangyari in the past. Bumili lang tayo ng equipment, pero hindi natin nalilagay. So mas maganda siguro, wala pa yung gamit, pag-isipan nyo na paano mo gagamitin. Ano po, tapos yung napag-isipan nyo, sulat nyo, then let's submit it to possible funding agency. But currently, we have a window for next year. Actually, this year. Pero we're now starting to list. So, kung kakayanin po ng digital agriculture na finance, we'll do that. Pero, mas magandang justification that we already have a research idea in mind on using that. Ano po? Hindi lang pa laboratory nila. Ano po? Aside from laboratory nila, nagamit na din mga teachers in fact. Yun lang po. Pero I learned we also have a spectrometer.
You will also have a spectrometer, the CI710S.
Okay. Ano gamit niya?
CI710S is to measure yung spectral signature ng dahon. So, yung spectral signature ng dahon ay marami kang matideduce na information doon. So, it's a device you click on a leaf and then it picks up the signal, the spectral signature of your leaf. So, yung spectral signature I think it's from 400 to 1100 nanometers. So kung wala po kayong knowledge about spectroscopy, read about light and the light spectrum. Makikita niyo po doon yung bands ng light. So itong ating yung nakikita natin, okay, nakikita ko yung kulay puti, kulay itim, kulay red na shorts, kulay black na shoes, kulay red na shoes. Yan, that is, may spectral signature yan. Kaya ako nadidetect yan kasi yung mata ko mayroong ability to sense that spectral signature. Kaya ako nai-interpret as a color black or as a color red kasi yun yung in-input sa brain ko na information when I was growing, diba? Tinuruan tayo na black ito, red ito, blue ito, yun. So, yung sense of yung CI710S, kukunin niya lahat yung signature, yung information noong any object na tinamaan nung tinamaan ng sensor na yun. So, isa siyang curve. Lalabas sa kanyang data ay curve. Ang tawag doon, spectral signature. Okay. So, yung spectral signature na yun, it will tell you a lot about nutrient status, about moisture content. So, pwede mo siyang gamitin sa grains, pwede mo siyang gamitin sa leaves, pwede mo siyang gamitin sa bark, pwede mo siyang gamitin sa soil, pwede mo siyang gamitin sa fruits. Okay? Pero yung leaf spectrometer natin, yung CI710S, is designed for leaf. There are spectrometers that you can use for different applications. So, marami kong information matideduce noon. Kailangan mo lang i-analyze parang isa pag beses. Kung halimbawa gusto mong mag-analyze ng nutrient content, kailangan mong i-subject yung samples mo into wet chemistry analysis. Tapos, i-regress mo ngayon yung value na na-derive mo using wet chemistry method doon sa spectral signature. Pag nakakuha mo na yung relationship na yon, lalabas ka na lang sa field, gagamitin mo yung device, pipindutin mo yung device, papasok mo yung lead, pipindutin mo yung device, papakita na lang sa'yo yung relative measure of the parameter that you use for addressing the spectral signature. So hindi mo na kailangan ulit mag-wet chemistry analysis. So napapadali yung proseso mo kasi you have the spectral signature of your sample, and then you can just simply use the model that you put in doon sa device na yun para ma-generate or ma-analyze yung iba pang mga samples. So it's a very powerful device to have, but you have to understand you have to have a basic understanding of spectroscopy at saka yung tinatawag na chemometric science. So si food science, may knowledge yan sa chemistry, di ba? May knowledge pa sa chemistry. Alam niyo po yung chemometry. Napakinggan niyo na po ba yung word na chemometry? So yung chemometry is yung parang metrics ng chemistry. Okay, it's the metrics of chemistry. So you just put numbers into the chemical composition or chemical properties of an object. So very high level science, high level statistics, yung knowledge na yun, pero it can be learned. Okay? So it can be learned. So there's a lot of resources that you can use to. So since my device na kayo, it will come soon. Start reading up on what that science is all about and how you can use that for your research. So, ang kagandahan nito, you start to become familiar with this instrumentation at this very early stage. When I was doing my undergraduate in Los Baños, I've never held a device similar to these devices na nasa sa inyong reach. Okay? Naalala ko, nung nag-measure kami ng photosynthesis, we have a certain contraption. It's called a photometer. So it's a beaker, and then that beaker is connected to a column of water, and then that column of water is connected to a test tube, and then that test tube has a stem, a plant stem. Naka-enclose si plant stem doon. So, tapos ilalabas namin siya doon sa sunlight para mag-transpire yung plant. Doon sa column ng water na yun, may bubble. So yung bubble na yun, mag-move kasi isasak ng plant yung water na doon sa test tube. Okay. So yung rate ng transpiration is determined by the rate by which that bubble is moving through that column. Yun yung ginamit namin sa rate ng transpiration of the undergrad. It's called the photometer. Okay. So I didn't occur to me na meron na palang photosynthesis machine, and you can measure photosynthesis by looking at the gas exchange. Okay? Yun yung mas accurate measurement ng photosynthesis. Yeah. So sooner or later, you will have more devices kasi marami pa tayong devices that you can use. As I said earlier, in measuring photosynthesis, you can also use light. Okay? There's a machine called the fluorometer. You don't need gas exchange technique. The science behind fluorometry is so established. You can just shine a light on a leaf sample. It will tell you the rate of photosynthesis, the electron transport rate, and other different parameters like stomatoconductance, tumutubo na ba yung ilong nyo? Yun. So, yun yung mga parameters na pwede nyo i-measure para ma-determine yung this is high-level physiology. Okay? So, at this very early stage, you are becoming expose na kayo sa ganitong mga instrumentation, and there are heaps more out there. Marami pang ibang mga instrumentation that you can use. So, sabi ko nga sa inyo, just sit back, relax, and enjoy the ride. Alright, masyado na akong bolero. May tanong pa ba? Wala na. Ambus na. Okay. So with that, thank you very much again. I don't know whether we still have time for the demonstration downstairs. So we have those devices, I can show them to you. If you still have time, you're more than welcome to go downstairs to view the device. But I think it's only the students allowed. No, unfortunately, not the students just yet. So when I give the training to the faculty members, down the track, you will get an opportunity to do that as well through your teachers. Thank you.
Dr. BENG UMALI for generously sharing and answering those fears of our faculty and students. So may we proceed now for the awarding of the certificate. So allow me to read the citation. Certificate of commendation is hereby given to BENG UMALI for his valuable insight as resource person during the soil plant atmospheric Continuum, an introduction, and IoT-enabled sensors held on March 22, 2020. The 22nd day of March 2020 at the Auditorium, CBSUA San Jose Pilicamarine, first signed by our SUC President for Algeria to end of year. Award of certificate figures again request our Director for Extension Division of our Vladimir Honda and our Chairperson of BA BISAF BS Agroforestry Program, Gina Velasco. Before we permit this seminar or event, in behalf of the organizing committee of the CBSUA, IC, and EST in partnership with the CANR, SEPS, CIT of Sipopot, we would like to express our heartfelt gratitude to everyone for attending and joining us for today's seminar on soil, plant, atmosphere, continuum, on introduction and IoT-enabled sensors. So once again, thank you very much for the students now in first grade today at our festival activity at our new building ground. Okay, so so the organizers are requested to have the photo opportunity first with our resource person.